Hello Year 11. Today we're going to be having a look at, given one trigonomic ratio, finding another one. Now we've actually had a look at this already. We looked at only our acute angles in the first quadrant. What we're going to have a look at is applying that rule and seeing that there are actually other answers to our questions that happen in the other quadrants, the second, third and fourth. What this will allow us then to do will be to jump over to our lovely little textbook and have a go at exercise 5F, which I'll show you that in the end, where that is. Okay, so let's have a look at the little dot points at the top up there. It says, when given a ratio and asked to find another, it is important to. The first one, I think, is extremely important, drawing a triangle. So I want you to always draw that triangle. The second point, using Pythagoras. So often we're going to only have a couple of sides on that triangle known to us. We're going to, like we would back in year 9 and 10, use Pythagoras to find the third side because we'd be drawing that into a right angled triangle, so we can do that. Then we're going to apply our all stations to central for our quadrants, have a look at where our trig ratios are positive or negative, pick the right one and go from there. You guys did really well at this when we looked at the first quadrant acute angles. We're just going to apply it to the next quadrants and you guys will be great at it. Okay, so let's have a look at question 1. It says, if sine of x is equal to minus 5 over 13 and cos of x is greater than 0, find the exact value of cos of x and cot of x. It looks like a little bit of a mouthful, a lot of words there. We need to break it down. Remember, I want you to look at the question part by part. The first part says, if sine of x equals minus 5 over 13. Now we can do something with that. We can draw ourselves a right angled triangle. I want you to start with to ignore that negative sign because that's not going to come into play just yet. We're going to look at sine of x is equal to 5 over 13 to start with. So let's go over here and draw ourselves that right angled triangle. Okay, we'll pop an x down there. Sine is opposite on hypotenuse. Opposite is 5. Hypotenuse is 13. It's a right angled triangle. We know two sides, so straight up we can find that last side. So using, oops, excuse my computer on these videos, using our Pythagoras' rule, we know that 13 squared equals 5 squared plus our unknown here. I think I'll call that y. So 13 squared equals 5 squared plus y squared. 13 squared minus 5 squared equals y squared. Working that through, I'm going to end up with y is equal to the square root of 144, which is 12. So if you need more time to work that through, do that. You should be quite familiar with Pythagoras' theorem at the moment. So we've ignored the negative, we've put our values in there, and we've got some information. Now let's look at the next part of our question. It says, and cos of x is greater than 0. So it's just saying that cos of x is positive. So we know things about that. We can look at our quadrants. We can go, okay, all stations to central. We know cos is positive. Where is cos positive? Cos is positive in this quadrant and in this quadrant. But remember our question where our blue is over here. I said to us for us to ignore the negative to start with. Now is when we're going to put that negative into play. So we said sine of x was equal to negative 5 over 13. So sine is negative. Where is sine negative? Sine is negative in the third quadrant and the fourth quadrant. So where these two things occur, where sine is negative and where cos is positive, is in that fourth quadrant. So that's where we want our answer to take place, is in the fourth quadrant. Okay, so we've just selected that first part of the question. We know sine of x, we know it's negative, we've got a value, we've found our third side of the triangle, cos is positive. Now it says, find the exact value of cos of x and cot of x. Well, let's break it down again and let's find cos of x. Now, that's a nice and easy one. Cos of x, we're in that fourth quadrant. We can go over to our triangle here. Cos of x is adjacent on hypotenuse, so cos of x is just going to be, sorry, we're jumping around here, 12 over 13. So that's a nice simple one. Okay, next part. Cot of x. Cot of x. Let me think what cot of x is. Cot of x is 1 over tan of x. Okay, which is 1 over, what's tan is opposite on adjacent. So by flipping that upside down, I get that cot of x is adjacent over opposite. So it's just the other way around. Okay, so if we go over to our triangle again, we've got over here adjacent to x is 12 and opposite is 5. Oops, sorry, got to pick that pen up again. 12 over 5. Now, what we need to think about though is what is happening with the sign of cot in that fourth quadrant. Okay, we've worked out our fraction. Remembering we are still in that fourth quadrant. If we need to, we might need to highlight that. We're in the fourth quadrant. We are dealing with tens and cots, and they are negative. So our answer is going to be minus 12 over 5. So we've got our two answers there. We've got cos of x is 12 over 3 and cot of x is minus 12 over 5. Okay, let's move on. Okay, so question 2. Given that cot of alpha is equal to minus 15 on 8 and that 90 is less than alpha is less than 180, find the values of cosec alpha and cos alpha. Okay, a lot of you will get into questions like this and you will look at them and you will go, it's too hard, I don't understand what it's saying. But what we're going to do, again, as we normally do, is we're going to break that sentence up into little sections and understand it section by section. So we're going to go to the first part up to the comma. It says, given that cot of alpha equals minus 15 over 8. So to start with, we're going to forget that minus sign there and we're going to only look at cot of alpha being the being 15 over 8. So I'm going to write that down there. Now, we need to think about what that actually means. Now, we're thinking about what cot means. Cot is basically tan flipped upside down. So we were saying cot of alpha is 1 over tan of alpha, which is 1 over, what was tan? It's the TOA, it's opposite on adjacent. So cot of alpha is actually adjacent on opposite. Okay, so we want to remember that. Or you're going to need to work it out each time. So what we can do with that is we can pop that information into our triangle and draw that in. So let's draw our right angle triangle again. Alpha's down here, or you could pop it up the top if you want to use that spot to put alpha in as well. So in this case, this is something we're not normally used to doing, but cot of alpha is adjacent on opposite. So our adjacent is going to be 15 and our opposite is going to be 8. So before I go back to the question, I can see that I'm in a right angle triangle and I don't have any value for the hypotenuse of that triangle. So let's work it out. So x squared is 15 squared plus 8 squared, which is going to be equal to 15 squared is 225. 8 eighths is 64. If we add those guys together, we're going to get 289. So x squared is 289. Taking the square root, x is going to be equal to, remember we're looking normally at the positive and negative version. In this case, we're allowing you to look only at the positive version because it is a distance. So I don't want negative 17. In this case, I only want 17. Okay, so let's go back and have a look at the question. We've done the first part, telling us that cot of alpha is 15 over 8, but we're also wanting to have a look at the minus in front of the 15 over 8. So if I draw an all stations to central, diagram again, okay, where is cot negative? Cot, which is tan, is going to be negative in the second quadrant and the third quadrant. But now we want to have a look at that next part of our question where it says and that 90 is less than alpha, which is less than 180. That pops us into the second quadrant. So we are working now in that second quadrant, and that's what we want to deal with. So now we have enough information to find the value of cosec alpha. Now, cosec, what does that match with? You can go back to your formula sheet from the HSC and find that if you don't remember. I always remember because that third letter there is an S. It's to do with sine. So cosec alpha is equal to 1 on sine of alpha, which is equal to 1 over, what is sine? Sine is opposite on hypotenuse. So if we flip that upside down, we're going to get hypotenuse on opposite, which is what our cosec alpha is going to be. So hypotenuse over opposite is going to be 17 over 8. Okay, so now we've got our answer 17 over 8. Let's just check that we're happy with that. We're in the second quadrant. We said sine and cosec were positive. We've got a positive answer, so we're okay. That's looking good. Okay, let's have a look at B. B is cos of alpha. Okay, so cos of alpha is a little bit easier. We can go straight into our triangles and we know that cos is going to be adjacent over hypotenuse, which is 15 over 17. Oops, put an S in there. But we need to think about the sine of the angle. So we're in the second quadrant. What happens in the second quadrant? Cos is negative. So we want to have minus 15 over 17. Okay, so I think as long as you guys are reading the question part by part, answering or gathering your information from the question in sections, it's not going to be as difficult. Drawing your diagrams for the triangles, drawing your all stations to central and figuring out what quadrant we're in and what sign we want to deal with. What trig function we want to deal with. You'll be perfectly fine at these questions. The other two things I wanted to have a look at down a little bit below are a couple more trig identities, which we looked at the other day. The first one being that tan of theta is sine of theta on cos of theta. I proved that one to you the other day, but I can show that to you again. So we know that sine of theta is equal to opposite on hypotenuse. We know that cos of theta is adjacent on hypotenuse. And we know from our formula sheet and showing you the other day that tan of theta is sine of theta on cos of theta. So if I was to pop in opposite on hypotenuse divided by adjacent on hypotenuse, we can cross out those h's, or if we do it the long way, we're going to have over a over h divided by a over h, which becomes o over h times it, flip the second one, h over a, the h's cancel out, and we end up with o over a, which is OR, which is the ratio for tan. So that's where it comes from. You might need to do that later on in the next week when we look at some more algebra using these. But likewise, because tan of theta is sine over cos and cot is 1 over tan, we can basically just flip our tan theta upside down and become cos over sine for cot. Looking back to our ratios on our HSC sheet, so there's our HSC formula sheet. We get given these ratios here in yellow, so you're not needing to memorize all of those anyway. So it's got the equal of a's, cos over sine, we've got the sec, we've got the cosec, you've got your triangles, and you've got your normal trig function. So those are there for you anyway. It's just often a little bit quicker if you can remember them, but they're there for you to have a little look back at as well. Okay, I just want to quickly look at some complementary angles as well. So we've actually looked at these complementary angles before. You guys have actually been using these since probably year 8. You just probably don't know that you've actually been using these. So let's have a look at the first one. Sine of theta equals cos of 90 minus theta. If I was to draw that right angle triangle and pop in my theta there, what we could actually say was that this third angle in my triangle is called 90 minus theta. Because we know that all the angles of a triangle add up to 180 degrees. So 180, take away 90, I'm only left with theta and whatever this angle is. So it has to be 90, take away this angle. And that gives me my third angle in there, 90 minus theta. Now, let's do sine of theta is equal to opposite on hypotenuse. Pop adjacent in there as well. And sine of, well actually not sine, it's going to be cos, sorry. Cos of 90 minus theta is going to be adjacent on hypotenuse, which is also opposite on hypotenuse. So, based on the other theta. So what we actually find is that sine of theta and 90 minus theta are the same if we're basing our opposite, adjacent, and hypotenuse off that first theta. And that's where our first rule comes. So you probably haven't really thought about it, but we've actually been using it based on the angle sum of a triangle quite some time. The same would apply for the cosec theta is sec of 90 minus theta, and tan of theta is cot 90 minus theta. These just may come in a little handy occasionally, these rules, in order to work out some answers a little bit quickly. Okay, year 11, we now have the ability to work through exercise 5F. I want you to go over there and start working through that. The questions I suggest are in the work schedule. You can jump around, change those around if you like. Make sure you mark them. There's another nice example there to have a look at. That's also been worked, that example 11, in our OneNote down the side here at 5F if you want to have a look at that one as well. Just some same working, just without me talking through. Good luck. I'll see you guys later.